Hi everyone, I'll be starting off our presentation and our group consists of me, Li Ka-xiong, my friend Ku Shi An, Mikhail Gabriel Pinto and Egan Yap Hong Yi. We'll be starting off with introduction to Sunway Bank. So Sunway Bank is one of Malaysia's top financial bank. It's well known for its effective financial services and large customer base. The management has decided to strategically open 3 additional branches in Johor, Malacca and Sarawak in order to enhance its reach and serve its expanding customer base. This presentation outlines the networking infrastructure requirements between the bank's corporate office and its new branches while taking into account the bank's history, its business operations and the major networking challenges the bank sector is currently facing in the digital era. So now we're going to dive into the background of Sunway Bank. As a full-service bank, Sunway Bank serves its clients with a variety of financial goods and services. It has developed a reputation for dependability, security, and client fulfillment. Due to the constant nature of financial transactions across time zones, Sunway Bank's business operations are built to provide round-the-clock availability. The bank wants to give its employees and customers a safe working environment while still ensuring the confidentiality, availability, and integrity of important financial information. So now we'll be moving on to networking challenges. The banking sector is currently facing a number of significant networking issues. Designing and implementing Sunway Bank's network architecture requires recognizing and addressing these issues. The following are top 5 networking challenges. First, digital transformation and innovation. Digital transformation and innovation are essential for banks to be competitive as technology develops constantly. Adopting cutting-edge technologies like the blockchain, mobile banking, cloud computing, and analytics powered by artificial intelligence calls for a flexible and agile network architecture that can easily incorporate these developments while upholding security and compliance. Next, we have compliance and regulatory requirements. The banking sector is subject to strict rules and compliance requirements for clients' protection, financial reporting, and data privacy. To comply with rules and avoid penalties, networking infrastructure must have data retention policies, access controls, audit trails, and monitoring tools. Thirdly, we have network reliability and availability. Networks must be extremely dependable and accessible for banks to guarantee that customers receive services continuously. Network issues or downtime can cost bank money, erode consumer confidence, and harm its reputation. To reduce downtime and guarantee company continuity, redundancy measures, fault-tolerant designs, backup connections, and disaster recovery strategies are essential. Fourth, we have network scalability and performance. Banks must be sure their networks can handle rising traffic volumes, support high-speed data transfers, and maintain consistent performance to deliver a smooth user experience in response to the increased demand for online and mobile banking services. It is crucial to have scalable network architecture, optimized bandwidth usage, and effective routing protocols. Lastly, we have security and data protection. Banks manage private consumer data, money transfers, and confidential information. It is crucial to protect these data against cyber threats, unauthorized access, and data breaches. It is crucial to put in place strong security measures including firewalls, intrusion detection system, encryption methods, and access control. That is all for my part. I will now pass down to my friend Ku Shi An.
Hi, my name is Kushiran and I'm going to present LAN network infrastructure. So for our LAN infrastructure, the network devices that we use is the core switches, normal switches, access point, and network security appliance. For the topology, we use star topology, and for our services, we use firewall, CCTV, and VPN. So right now we are going into the LAN physical diagram, and this is floor 1. So floor 1 is the lobby. So as you can see, there are 4 ATMs, a receptionist table for the employees, and we got 5 CCTVs for safety purposes, and we got AP or access point. And then as you can see, the AP connected towards the switch 1 or the normal switch, and the 4 ATMs connected to the switch 1. And for the green line is connected from to floor 2 and floor 3 for the switches, the normal switches, and they are called switch 2 and switch 3. And for the orange line over there, the orange line is connected all the way to floor 5, and that is connected to the core switch. And we got an elevator and a staircase that will lead the employees all the way to floor 5. So right now we enter to floor 2 for our LAN physical diagram, and this is the office room. So as you can see on the desk, there are 6 PC or laptop computer. So there are 6 computer over there, and then that is for the employee to use. And then we have 4 CCTV to monitor and the AP access point. So for the AP, as usual, it will connect to the switch 2, and for the 6th computer, it also will connect to the switch 2. And as you can see, the green line, switch 2 will connect to the switch 1 and switch 3, and then for the orange line, it will directly connect to the core switch. So right now we enter floor 3 for the LAN physical diagram, and this is a security room. As you can see, there are 2 PC computers in the security room on the desk with 6 monitors. So this is for the employees, the security employees, to monitor the entire bank. And then we have 4 CCTV in this floor to monitor around too, and we have an AP to connect the switch 3, and the 2 PC also connect to switch 3, and the green line will be connecting to floor 1, floor 2, switch 1 and switch 2, and the orange line will be connecting to the core switch, and that is in floor 5. So right now we are in floor 4 for the LAN physical diagram, and this is the mainframe room. As you can see, there are 4 CCTV to monitor the mainframe room, and there is an AP, and there are 3 mainframe in the mainframe room. There are the database, the storage, and the backup database. As you can see, the black lines are connected to the core switch that is in floor 5, so it will be going up through the walls of the building. So that's why you can see the diagram is connecting downwards towards the floor 5. And we have a staircase and elevator too to connect to this floor too. Okay, so right now we are in floor 5 for the LAN physical diagram, and this is the server room. As you can see, we got 4 machines over here. We got the DNS, we got the VPN, data server, and storage maintenance for the PC. And 4 of these connected to the core switch. And then as you can see from the black lines from the top to connected to the core switch, that is from floor 4. As I say on the previous slide, that is connected through the walls towards floor 5 from the mainframe room. And then we have the AP connected to the core switch too, and we got elevator, a staircase, and 4 CCTV. And as you can see, the red line over here from the core switch, it will connect to the firewall for safety protection, and the firewall will connect to the router, and from the router we have a backup server if anything happens for safety. So this is the entire bank LAN diagram. As you can see, floor 1 is on the top left, and then floor 2 below floor 1, floor 3 below floor 2, and on the right is floor 4 and floor 5. So as you can see, the lines, the orange line is connected all the way to floor 5, whereas the black lines are connected to their switch, and the green lines are connected between the normal switches from floor 1 switch 1 to floor 3 switch 3. And that is all for me.
The proposed solution for network equipment is that it sets up enterprise-grade routers and firewalls at the main office, and each branch to handle VPN security and routing tasks to provide effective local connection and VLAN segregation. Managed switches need to be placed at each site. Wireless access points are further advised for Wi-Fi coverage. The proposed solution for connection establishes a site-to-site VPN connection as well as MPLS connections. While VPNs guarantee encrypted connection over the open internet, MPLS offers specialized and secure connectivity ideal for sensitive financial data. To guarantee network availability, redundant high-speed internet connections must be installed at each location. The proposed solution for services help unify user management, use centralized authentication services like Active Directory, utilize VoIP for efficient and transparent branch-to-branch communication. Virtual meetings and cooperation will be made possible via video conferencing systems. For effective data management and disaster recovery, centralized data storage and backup solutions should be taken into consideration. The chosen networking equipment guarantees safe data transfer and network administration. Routers and firewalls enable restricted access while defending against online dangers. Wireless access points offer simple connection while managed switches improve the performance of the local network. Performance and security are balanced through MPLS and VPN connections, while VPNs offer secure online communication, ideal for less sensitive traffic. MPLS ensures a dedicated and predictable conduit for vital data. The likelihood of network failures is leading to downtime is decreased by redundant internet connections. Access control is streamlined, security is improved, and user administration is made easier with centralized authentication. VoIP offers crystal clear audio quality while enabling cost reductions on communication expenditures. By facilitating virtual collaboration, video conferencing systems help to cut down on the need for in-person meetings and increase productivity. Solutions for centralized data storage and backup aid in effective data management, accessibility, and preparedness for disasters. This package of services satisfies the unique requirements of the financial sector while adhering to regulatory compliance. In conclusion, to construct a strong WAN network infrastructure connecting the bank's branches and headquarters, the suggested solution includes secure networking equipment, dependable connections, and necessary services. This configuration fosters internal cooperation and scalability while ensuring safe, effective, and compliant communication.
This is Mikhail and I'll be presenting about the network diagram for bank headquarters. Firstly is the internet, which is connected to a router and a backup server. The router is then connected to a firewall, which is connected to 3 switches and a core switch. The first switch is connected to 4 ATMs, an AP router, which is connected to 5 CCTVs. Second switch is connected to 6 PCs, AP router, which is also connected to 4 CCTVs. The third switch is connected to 2 different desktops, which are linked to 3 different monitors, and an AP router, which is connected to 4 different CCTVs. The core switch is connected to 2 different floors. The first floor connecting to storage mainframe, database mainframe, and backup database mainframe. Is also connected to an AP router, which is connected to 4 CCTVs. The other floor is connected to a DNS server, data server, VPN server, and maintenance server, and it is also consisting of an AP router with 4 CCTVs. Next, I'll be presenting about the network diagram between all branches and headquarters. It firstly starts with the headquarter with a PC and a server. It's connected to a switch which is connected to the internet, and between the internet and the next router there is a firewall to prevent any malicious interference. The router is then connected to 3 different routers across all the different branches. They are all consisting of a switch and 2 different PCs in branches located from Malacca, Selangor, and Penang.